In this video, I'm going to talk about vectors and how we can deal with them in the coordinate plane. So first, let's talk about a vector in standard position. If a vector is in standard position, then its initial point is at the origin. So if we're looking at our diagram here, we've got two vectors, OR, and when we're looking on the coordinate plane, we'll use the starting point and the ending point, then use our vector symbol. That is in standard position. In the coordinate plane, we deal with how we represent the vectors a little bit differently. Rather than a magnitude and a direction, we're going to use the ordered pair representation. So the ordered pair representation shows us how far in the x and y directions that the vector goes. So if I wanted to represent OR, we use, they're called echelons, or we can call them pointy brackets, whatever. And then we look at how far, if I'm going from O to R, we're going 3 in the x direction and up 4 in the y direction. So it'll be 3, 4. So it's going to look like a coordinate, but rather than using parentheses, we use the echelons to denote that we have a vector. Next, equal vectors. Okay, pretty straightforward. Vectors are equal if they have both the same magnitude and direction, but they don't have to be in the same location. So both of these go over 3, up 4, over 3, up 4. So OR and ST are equal, and they both equal 3, 4. All right, so we've got this diagram here. We're going to name the ordered pair whose representation is shown in standard position. So that's going to be OA, and it goes over 4 down 2. So its ordered pair is going to be 4, -2. Two vectors that have the same ordered pair. So looking at our diagram here, this vector and this vector are equal. So OA is equal to vector BC. Ordered pair for DE, we're going back 3 and down 5. So we'll have -3, -5. And then if the ordered pair represented by FG were shown in standard position, what would the coordinates be of its terminal point? So if we were to take this little vector here and slide it up to here, well, it's going over 2, up 3. So if we moved it over here, it would go over 2, up 3. So we'd have -2, 3. Okay, next we're going to sketch OH, OI, and HI, given that O is at the origin. So we'll start with OH. So O is going to be here. -3, +2. So OH is going to go right there. We'll draw OI is 2, 5. And then our last vector we're going to draw is HI. So we're going to start at H, go to I, which goes over 5 and up 3. So its ordered pair will be 5, 3. So now you can try this one. So OH is 1, 4. So it looks like that. OI is 2, -3. When we go from H to I, we're going 1 in the X and -7 in the Y. Okay. Then we have the magnitude. So remember, our symbol for magnitude is absolute value. But this is pretty straightforward since this is the change in X and the change in Y, and we're looking at the length. It's really just the Pythagorean theorem. So it's going to be the square root of x squared plus y squared. Okay, so we're going to find the ordered pair that goes from point A to point B, then we're going to find the magnitude. Okay, well, we're looking at, if I'm going from this point to this point, what's our change in x, what's our change in y? So we're going from -1 to +3. So we're going 4 in the x direction. We're going from 5 to 7. So we're going 2 in the y direction. Then for our magnitude, we'll have the square root of 4 squared plus 2 squared, which is 16 plus 4, or the square root of 20. So give number 2 a try. Okay, so we're going from -3 to 5, so that's +8. Going from 10 to 4 is down 6, so we get a -6 there. And then when we do our Pythagorean theorem, we get the square root of 100, which is 10. Operations in ordered pairs are actually pretty straightforward. These are basically essentially our components. So if I wanted to add A and B, we would add the two x values, and we would add the two y values. Subtraction follows. Okay, and then k is what we call a scalar. Okay, it's just a constant. If we multiply a vector by the scalar, then we just multiply each element by that scalar. Okay, so we're going to find the magnitude of v if v is all this. So first I'll go ahead and distribute. So we're going to have 6, -4, plus -1, 5. And then add the individual elements. So 6 minus 1 gives me 5. -4 plus 5 is 1. And then ultimately we want the magnitude of this. The square root of 26. Okay, so parallel vectors, we have a diagram here, lots of parallel vectors that either have the same direction or opposite direction. And we can accomplish that if A and B are parallel, if there's some scalar that you can multiply A by to get B. So we'll look at this diagram. The ordered pair for V is 2, 3. Okay, K1V, so here's K1V. We're going over 4 up 6. So the scalar that I would multiply this by to get this would be 2. This one is -2, -3. So my scalar is -1. And then this little guy goes over 1 and up 1.5. So the scalar would be 1/2. Okay, perpendicular vectors, their directions are going to be 90 degrees apart, perpendicular. So one tool that we can use is something called the dot product. So the dot product is one way that you can multiply vectors together. Okay, and the symbol is literally a dot. You need a dot there. There is another version of multiplying vectors called the cross product, but we're just doing the dot product here. Pretty simple calculation. It's just going to be A1 times B1 plus A2 B2. Now there's so you'll end up with a scalar answer. You're going to end up with just a number. For our purposes, we are going to use it because if A dotted with B results in 0, then that means A and B are perpendicular. Okay, so how do we use it? Obviously first, to show if vectors are perpendicular, we can just do the dot product. Okay, so we multiply the x's, and then multiply the y's. -5 times 1 is -5. So we get 3. 3 doesn't equal 0, so these are not perpendicular. This one here, okay, would multiply 2 times 10 plus negative 5 times 4, which is 20 minus 20, which is 0. So x is perpendicular to z. We can also use the dot product to determine parallel. We kind of got to be a little bit clever to this, because really all the dot product is going to tell us is if they're perpendicular. But we can use the fact that if you have two lines that are parallel, if one is perpendicular, if we could show these are perpendicular and these are perpendicular, then they're parallel to each other. Okay, so what we're going to do is we're going to change one of these vectors to a perpendicular vector. The way we will do that is we're going to switch x and y and change the sign. So think about like slope. If I had a slope of 2/3, the perpendicular slope would be negative 3/2. Well, translating that to our vectors, our change in, this is essentially change in y over change in x. Well, if I swap my change in x and change in y and make one of them opposite, then we get a perpendicular vector. So you can pick whichever. I'm just going to make what I'm going to call perpendicular b. I'm going to switch these two around and change one of the signs. Okay, so I'll swap the 6 and negative 3 and make the negative 3 negative or positive. You could have also done negative 3, negative 6. That would work. So I'm going to take A, dot it with perpendicular B. And we get negative 12 plus 12, which is 0. So A is perpendicular to perpendicular B, which means, and B is perpendicular to perpendicular B. So A is parallel to B. All right. So we'll take this a step further and decide if we have two vectors, are they parallel, perpendicular, or neither, which is also an option. So first we'll start just doing the regular dot product. Here I get 30 minus 30, which is 0. So I don't have to do anything further because A and B are perpendicular. Okay, second one, we'll start that way. So we get negative 3 minus 12, which is negative 15. Which isn't 0, so they're not perpendicular. So then I'll do this again. I'm going to create a perpendicular to one of these. I'll just make a perpendicular B. So switch x and y and make one of the signs opposite. We get positive 6 minus 6, which is 0. So A and B are parallel to each other. Okay, then my last example, we're going to find the value of k that makes the vectors A perpendicular and B parallel. Okay, so if they're perpendicular, I want the dot product to equal 0. So I'll go ahead and do the dot product and set it equal to 0. And now I have an equation we can solve. So k to make them perpendicular is going to be 9. For parallel, I'm going to go ahead and make, I'll switch it, and I'm actually going to make this 6 negative just for, why not? So we'll do 3 times k plus negative 2 times negative 6 equals 0. And we get negative 4. So you can try the next one. Okay, so if we do that, do the dot product, set it equal to 0 for perpendicular, we get 25 halves. Make a perpendicular vector. do the dot product, set it equal to 0, and we get negative 8. And that is how we will find, or we define vectors in the coordinate plane.